All right, welcome back to another exciting lecture on the atmosphere, chemical composition therein, and some new developments that we see in the historical or the geologic time scale. Yesterday we left off on the components of the ancient atmosphere, and I introduced methane gas, CH4, carbon and 4 hydrogens, nitrogen gas, N2, 2 nitrogen atoms bonded to make a nitrogen molecule, water vapor, the gas of water, H2O, 2 hydrogens and 1 oxygen, oxygen gas, O2, which was very limited in the early atmosphere's composition. And we'll see today where all the oxygen came from in our current atmosphere versus the ancient atmosphere's original mix of gases. So, what else? What did I leave out? Oh, carbon dioxide. We still have a very small amount of carbon dioxide in our current atmosphere, and we had a even less carbon dioxide back in the ancient atmosphere at the roughly 4 billion year ago mark. Carbon dioxide, carbon C, dioxide meaning 2 oxygens, CO2. So we'll look at the impact carbon dioxide has on our climate, our weather. And it's interesting today, this morning, it's actually kind of chilly. I'm sitting out here on my pool deck with a sweatshirt and my winter hat because the atmosphere is so dynamic today. We have wind coming in from the north. We know northern latitudes are colder generally than southern latitudes, whereas yesterday's breeze was coming from the southwest, bringing nice warm Gulf of Mexico air up into eastern North Carolina. The wind direction has shifted. We're on the back end of a system that is moving northward and pulling on its back end, cyclonic action, northern air, cold, blowing on me. Anyway, we'll get through it. I sent you a new set of atmosphere slides called Atmosphere Slides Second Set, and that's going to pick up on some of the cycles that we see that occur within the abiotic environment, the water cycle, for example, the nitrogen cycle, and that combines abiotic and biotic interactions, and the carbon cycle, which also combines abiotic and biotic components. So, if you have looked at the slides, great. If you have access to them while watching the lecture, even greater. And if you are just taking notes to supplement your PowerPoint slides, that also works. So where I'm at on my screen is the Atmosphere Slides Second Set title slide. I'm going to advance it to the first content slide. It's labeled Our Umbrella. And we do have a natural umbrella of different gases layered throughout the atmosphere. Have you ever seen a bottle of salad dressing, like Italian salad dressing or oil and vinegar, where there are clearly 2 separate layers? You can shake it all up real good and it emulsifies for a moment. So the liquids are in suspension and they're evenly mixed, but after a very short period of time, the components of that dressing will settle out and the more dense liquid will fall to the bottom, like the vinegar. The less dense, the oil, will rise to the top. Our atmosphere is layered with different gases of differing densities, very similarly to a bottle of salad dressing. So in those different layers, we have different conditions, and those different layers of gases interfere with energy from the sun's penetration to the surface of the earth. And that's a pretty important aspect of creating a life-supporting environment here on our planet. So our umbrella, I'm referring to the ozone layer with our umbrella, and the way our atmosphere is set up into 4 main layers and some smaller layers within those layers. We'll define them throughout today's lecture, I hope. But our umbrella is a result of lighter gases, like I spoke about yesterday, that hot air rises and cool air condenses and sinks because of density differentials. The lighter gases, those that are less dense,